Hello and welcome to your introduction to the carbon cycle. If you look at box number 6 here on the periodic table, that is carbon. Carbon is an element. It sitting on the periodic table does not look all that special. It kind of looks like everything else. But let me just tell you that without this carbon, there would be no carbon-based life forms. There would be no life on Earth. So carbon is a hugely important element, and that is why we study it, and that is why we look into the carbon cycle and how carbon moves around our planet. So you might be wondering, why do we think carbon is so important? Well, I will tell you that without carbon there would be no life, and here is the reason. You see these green plants and these pictures here, kind of in the background of the pictures. Well, they are able to use carbon to create this little compound here, C6H12O6. That is more commonly known as sugar. And without sugar on our planet, we have no cute, cuddly koala bears. And all of these, even the little fuzzy, beautiful spider there, all of these things are going to die. Without sugars being created during photosynthesis, everything dies. And that's the sad fact of the world. Why am I talking about sugar, you might be asking? Well, if you look here, that's C6 there. That's C. That is carbon. And so that is kind of where carbon comes into play with life forms. And we will chat about this a little more here in a second. So we were talking about life forms, and life forms are really only just one aspect of where we would find carbon on our planet. In those life forms, we're usually dealing with carbon as a sugar, at least if we're talking about its importance to us as living things. Plants, if we're talking about plants, the plants are making the sugars. If we're talking about consumers, those consumers are going to be using the sugars. So, but in general, within the biosphere, we're talking about carbon as sugars. In the atmosphere, it's a little bit different. The atmosphere, usually we're going to be dealing with carbon in the form of CO2. That looks like a Z, but that's actually a 2. So CO2. And carbon dioxide is the most common form of carbon that you're going to actually find in our atmosphere. The same is true for our hydrosphere, and the reason for that is our oceans do a great job of taking carbon out of the atmosphere and dissolving that gas into the water. You've probably seen fizzy soft drinks, Coca-Cola, something like that, and the gases are dissolved into the soda, and that's really easy to see because it fizzes up when you open it. Well, the same is true for our oceans, though our oceans do not fizz up like giant pop cans. Our oceans do have gases dissolved into them, and a great deal of CO2 is actually stored in our hydrosphere as well. The lithosphere. The lithosphere, you might be wondering, well, how in the world could we get carbon stored into rocks or our soil or our Earth's crust? And the answer to that is, well, all these living things here, even this little beautiful frog with his red frog eyes, they're going to die eventually. And when living organisms die, their carbon stays with them. It gets passed into the soil. And once a part of the soil, they could be hardened into rocks. If they're compressed over a long enough period of time, you will form actually even fossil fuels, or fossil fuels are stored in the lithosphere. So let's chat maybe a little more about how things move around our planet in terms of carbon. So I've chosen a very simple carbon cycle diagram to show you how carbon moves around our planet. And it's a very simple concept. You've got carbon that's in the atmosphere stored as CO2 here. That CO2 can be used by plants during photosynthesis to make sugars. Once you've made sugars, those sugars could be consumed by organisms. We get this weird looking sheep creature. Okay, once consumed by the organism, these things could either die and put the carbon back into our lithosphere. From that point, they can maybe even become fossil fuels if they're stored long enough, or they could undergo respiration. Respiration, we think of respiration as breathing, but that's not entirely correct. Respiration is essentially when we are going to be using the sugars in order to give our living organisms energy. So when we use sugars, that C6H12O6 is broken down, and one of the waste products is CO2. So the sugars get used, and the leftovers, if you will, the byproduct is CO2. And during respiration, whether it's an animal using that energy, that sugar, or a plant using that sugar, the respiration has the same effect. It's going to put that CO2 back into our atmosphere. And we also have a relatively new way that we are altering the carbon cycle. We take automobiles and factories, and we take all these fossil fuels right here that were stored down below the surface of the earth, and we pump them and use the energy that was in those fossil fuels to make our lives easier. And while we're doing this, we're taking carbon that's been stored for millions of years, and we are putting it up into our atmosphere. So that is a general rundown of what's going on, kind of, with the carbon cycle. Also, why we think, as your science teachers, why we think the carbon cycle is so important to learn about. If you have any questions about these concepts, just ask your science teacher. Thanks.